Recording? Okay, I'm trying to screen record. Afternoon, comrade subscribers. Well, don't need you making noises. I thought this might be a bit interesting. I'm just working on this Grundy NewBrain store board. So the store board is what they call the RAM board in the Grundy NewBrain. So I'm just going through trying to design the SRAM, or design an SRAM version. I thought might be interesting just to kind of go through my logic, what I'm trying to do anyway. So this isn't a tutorial in Kicad, this isn't a tutorial on digital logic design. I'm not an expert in either. I'm just fumbling along trying to learn something. So what's the problem? What's the problem we're trying to solve? Well, the existing board at the moment gives 32K internally. So this is via two 16K banks. So we've got a 16K bank here and we've got a 16K bank there. So these are 16K by 1 bit. So we've got 8 of them, so there's 16 kilobytes. Because they're DRAM, we've got 7 bits here. The addresses are multiplex. We've got a row address and then a column address. So in this case here, because we've got 2 banks, we've got a RAS16 and a RAS32 signal. Now, for some reason, I don't understand is they pass through 33 ohm resistors. So we've got pull-up resistors here on the data line, but I don't know why they go through 33 ohm resistors. So I don't know if it's some sort of buffering because the signals are coming from a different board. I don't know. I've removed them in the SRAM case. Anyway, so that's what we've got at the moment. And then RAS16, RAS32 are generated by this kind of convoluted stuff up here. So if we go, big thanks to Brian Cockburn as well, by the way. Shout out to Brian, who's been helping me with suggestions, not treating me like a complete idiot. Thank you very much. It's like, why are you doing this? Why are you doing that? Why are you doing this other thing? So, okay, good point. So first of all, so one thing is, okay, we're going from DRAM to SRAM. So we need to kind of demultiplex the address, the row address and the column address, so that they present at the same time on the SRAM. So one way of doing that is to latch the row address. So we've got a latch here that's kind of clocked on the RAS signal. So we've got 2 RAS signals. We've got a RAS16, RAS32. We don't care which one goes active. So they're active low here. So we invert them so they go active high or something like that. And we don't care which one is active. So we've got 2 knots and an OR, which Brian pointed out is an AND. So I'll replace that. But what he also pointed out is that why are we generating 2 separate signals if we are just going to combine them again down here? Which is a good point, a valid point. Basically, I don't understand this original multiplexing logic, so I was just leaving it as is. But then I just got to thinking that it is a good point. So let's go back to the live schematic here. So converted basically to an AND here. So why not simplify this? So I did try to do it manually. But I was just too much for my little brain. I did digital logic in uni 30 years ago. I specialised in microwave engineering, so and then went into telecoms. So yeah, digital electronics design is not something I know anything about. But I'm trying to learn. Anyway, so to generate this RAS13 and RAS16 and RAS32 signals, well, we can see that we've got a refresh signal coming in here, which I assume this is like it's being buffered. That's why it's going through an OR gate. So we've got a buffered version of the signal, I guess. And we've got A14 from the main board. So 15th address signal. And basically, so we've got refresh and A14 going into this NAND gate here. And then we've got refresh and the inversion of A14 going into this AND gate here, which then go over to generate RAS32 and RAS16. in addition to this, well, I've just put this called magic. I don't know. This input here, which as you can see is, we've got this ADL 1/2, TVS, all these other signals, a couple of flip-flops, all to produce this second input. So basically, this basically can, all of this can basically be boiled down to either being a logic 0 or a logic 1 effectively, can't it? Because it's an input to these gates. So we can either get a 0 or a 1. And we've got two other inputs, refresh and A14. So we've basically got 3 inputs. So what I thought I'd try and do first of all is, so this is a logic gate simulator on academo.org. So I just did a Google search, and I've basically set up the same situation here. So here we've got refresh. I think you can probably, I don't know if you can rename them or something. Anyway, so this is the refresh signal, this is the A14 signal, and this is this magic signal coming in. So we've got refresh and A14 going into the NAND gate. So we've got refresh and A14 going into the NAND gate here, and then we've got refresh and the inversion of A14 going into the AND gate. So again, we've got refresh and A14 inverted going into this AND gate. And then we go over to the 2 NAND gates that produce the RAS32 signals. So we've got RAS32 up here. You see they're not connected. So RAS32 and RAS16. And then we have this additional bunch of logic here, which again is effectively a 0 or 1. So that's down here. So this can be 0 or 1 going into there. And then this here is my NAND gate down here into the latch to generate the RAS signal. So that's basically the RAS signal there. So basically just did a truth table. So 0, 0, 0 gives RAS of output 0. 0, 0, 1. Okay, we've got a 1. 0, 1, 0, no output. 0, 1, 1. Okay, we've got output. 1, 0, 0, nothing. 1, 0, 1. Okay, we've got output. 1, 1, 0, nothing. 1, 1, 1, nothing. Okay, I might have skipped some, I don't know. But basically what I figured out is that this magic value here, so this value here determines this value here, well, determines the RAS value here. Basically, if it's on, then the RAS is on. If it's off, then RAS is off, regardless of what these two are, like that. That's on. Okay, so we know that first. The only time, if both of these are on, refresh and A14, then it doesn't matter what value this is off. So basically that seems to be it. So if these are both 0, then it takes whatever this value is. If one of these is 1 and the other 0, so if that's 0, 1, or if it's 1, 0, then again, it takes this value down here. But if both of these are active, then it doesn't matter what this is, but it's always off. Okay, so we can simplify that, can't we? So I did another search, and we've got this online, okay, close that. So online minimization. So here we've got a 3 input truth table. So if we've got, here is refresh. I can actually do that. Yeah, refresh. And this is A14M. And then this is that magic value there. So what we basically had was, if it's 0, 0, 0, then output 0. If both of these are 0, then we take whatever that value is there. If, again, doesn't matter what these values here are, we take whatever value that is there. So we get 0, 1, 0, 1. Again, it's only when these two values are the same, so these 4 down here, that it's always 0. Otherwise, again, we follow the value of this magic column. So that's what we end up with as the output. So 0, 1, 0, 1, 0, 1, 0, 0. So let's see if we can. Okay. Something not guard. I've forgotten all the kanji. Doesn't like. Okay, doesn't like me putting the slash here, I think. All right, let's try that again. Input must be 1 character. Okay. All right, so we'll call that R for refresh. Probably said that the first time I didn't read it. And there we go. Okay, here we go. So that's what we want. And here's the minimal form. So basically invert of R and M, or invert of A and M. So that basically should be our RAS input. So it's already inverted. So it's inverted refresh. And so that needs to go through. All right, let me draw this up. Actually, let's switch to Kicad. So it looks like it should be. Okay, so let's get. I could probably reuse some whatever. We'll just do some new ones. What's an inverter? I don't know what an inverter is off the top of my head. Okay, so so 4. All right, inverter, and then put the rest over here. Okay, so it looks like what we want to do is this will be refresh. So refresh going into there, and the other one will be A14, A14M. So that'll be A14 there. Now, what we then want is, I think it was going into an AND gate, wasn't it? What's an AND gate? What's an AND gate? Is it 32? Quad input, no, that's OR. So that's NAND. Can I just do, if I write quad and quad, quad 2 input NAND, quad 2 input open collector 09, is that what I want? And we don't really use AND gates, do we? What's this? Oh, what's this down here? Sem4 LSOO, that's an AND gate. That's interesting. What is this symbol here? Sem4 LS00. Oh, that's interesting, isn't it? Ah, there we go. No, it's actually an 08. Sem4 LS08. Yeah, that's right. Why is that list? So there's a. I'm reusing an existing schematic, which I'm very grateful for, but it's got a couple of errors on it. Looks like that's one, or that might be my error. I might have. Anyway, all right. Sem4 LS08 quad and 2. That's what I want. Yeah. All right. So stick one there. Stick one there. And then stick the spares over here. Okay, so I think what we want is, I'll just draw a wire. Okay, and then on this input here we want magic. Again here. So we want it like that. Let's get these out of the way. Stick them over there. Okay. So we've got that, and then it was going into an OR gate, wasn't it? I think. Just going into an OR gate. What was that? Sem4 LS. 32 was NAND, wasn't it? That's a NAND. 4 was the hex inverter. 08 is an AND gate. 333 input NAND. Oh, okay. Okay, Sem4. Okay. Let's just open this up a bit more. NOR hex inverter. Dual 4 input, no, dual. Where's the OR gate? Quad 2 inputs. Oh, 32. Okay, all right. Okay. So I think basically it should be like that. Maybe. So I should be able to replace all of this. So I should be able to, well, I don't know why that, again, I don't know why that's buffered, but if I get rid of that, get rid of that, and that, get rid of that, Okay, so I think maybe I don't want to just move this up there. I can move this up. Move this over here. And maybe I can just do it like well, I don't even need that there, do I? Stupid. Just put that over. Come on. Okay. Let's move. Let's move this down here again. I need that there. Apologies. I was thinking that the whatever grid they used is slightly off. Bugger. There we go. Okay. So maybe we can do that. Maybe this is what we need to do. And actually what we can do is move this here. Now if I wanted to, rather than just labeling, I guess I could just stick that through there. No, I don't want touching there. Doesn't matter. But yeah, so that's magic there basically. Oh, again, it's bloody just off. So maybe that's all I need to do. Refresh A14, magic, going out to RAS. So down here, I can then get rid of this gate as well. And then we've just got RAS going in like that. So we can try, let's go back here. Can we just delete all these? Delete. All right, let's just see if we get similar behavior. That'll be magic down there. So what we want here is a not. Is that right? Not there. I don't know why. Anyway, so we've got two knots, and then we've got going into what did I say, an AND gate. Now this could be completely wrong. I'm just doing this off the top of my head now, and add another AND gate. There. And then from here, from this magic, we've got up to there, up to there. And then we go through an OR gate. There to there, there to there. And then let's check the output. Okay. So both of these are on, refresh and A14. It doesn't matter what this is, this will be off, okay. But if both of these are off, this is on, okay, that's good. If one of these is on, good. If the other one is on, perfect, there we go. That's it. Does that make sense? So I'll tidy this up, this is obviously a mess, but so what we've done here is we've taken the original logic, we've reworked it, so instead of having two separate RAS signals, we've now just got the single RAS signal, which goes down here into the latch, so that we can latch the row address into the SRAM and present at the same time as the CAS, and then we've just got A14 here, which actually we're not. Oh, I'm going to have to, yeah, so I'll have to put a label on here because we need the inverted well, we need the proper A14. Just stick that, I'll tidy this up anyway. So that's A14 there. There we go. Oh, I think that'll work. Well, the logic works. I don't know if the electronics is going to work. All right, so I'll tidy this up and I'll upload it to GitHub. Yeah, okay. Hope that makes sense. I hope that was interesting. Of course, please let me know where I've gone wrong. I'm happy to learn. I don't profess to be an expert. I'm learning this as well. But hopefully it makes sense. But yeah, please do let me know my naive assumptions. Okay, so now what do I do? I pause on here or pause on? Actually, I should. I'm supposed to let it running actually, so I have the end cards. So yeah, I just need to tidy up. So I don't need these down here anymore. Let's get rid of that. So let's get rid of those. So I don't know what I've removed up here actually. I need to have a look at the original here. U417 417 see that's wrong there, yeah. Which one's this one? U4. So yeah, U1. So the U417, U4. That's the original chips. And that's a U417 there. Okay. All right. Should be time to stop recording now. Okay. Hopefully that was interesting. Bye for now. Okay. And we're back. Okay. A little update. Sorry, this is on my mind a little bit. I can't think of anything else until I get this out of my mind. But there is an error on this schematic. So I didn't redraw these schematics. I'm not complaining. I'm not saying anything. I'm just saying there's a small error. The chip number's correct, U417, but this obviously isn't a SEM4LS00. So this isn't an AND gate. This should be a NAND gate. So this is U417, this one's U417, this is U417. So these are actually all on the same chip. So these should all actually be NAND gates. So we've got refresh A14 going in here, then we've got refresh and then inverted A14 going into this NAND gate. So that changes the logic a little bit. So if I go back to, so I've redrawn it. Here's refresh, here is A14M, and then we've got NAND gate. This was an AND gate, so this is now a NAND gate. And then we have this third input here, and then again we've got the two NAND gates, and then we've got the RAS32 and the RAS16. So if we go through the logic again, so we can see that when, oh, it's not moving anymore. Oh, interesting. I've broken it. Exit full screen. All right. Full screen mode. Doesn't matter. Okay. So we can see here that we can go through, actually what we want one input, don't we? So we know that basically we were going to have a NAND here. So I get one of these outputs, move that down to the NAND. So we've got RAS32, RAS16 going into this NAND, which is what we originally were going to do. But if we want to simplify it, right, there we go. So here we can see, well, if we go through our logic table again, so 0, 0, 0, output 0. 0, 0, 1, outputs 1. 0, 1, 0, output 0. 0, 1, 1. So again, it seems to be similar that we're following this value, isn't it? Then we go, turn that off. 1, 0, 0, it's off. 1, 0, 1. Again, it's this value here. 1, 1, 0, it's off. 1, 1, 1. So, matter of fact, it seems that it doesn't really matter what these two values are up here. It's all entirely dependent on this one down here. So, if we go back to, so this is all pretty much pointless. It all depends on this value here. I think that's right, isn't it? We've got the NAND going in there, so we've got NAND and NAND. So if I go back to this here, it's basically, we don't care about any of these values. We basically just want, what did I say? That's me getting my video ready. Yeah, so we want basically whatever this value is here. So we go back to Kicad, we can even get rid of that. So really RAS is, that value there. That just seems too simple. So whatever we get here, which is absolutely nothing to do with refresh or A14. Well, we've got refresh there. And we do have CAS here. But yeah, so essentially that's it. Seems too simple. But that's how the logic's working here. Refresh going into NAND, NAND, A14 going into NAND and inverting into NAND, which is what we had initially. Refresh going into NAND and NAND, and A14 going into NAND and inverting going into NAND, not AND. And then output going into NAND, output going into NAND, and then this value going out to, yeah. So if we get rid of that, so if we just look at what RAS32 would have been, and RAS16, so if we've got, so it doesn't matter what refresh is. Then what about A14? Doesn't matter what A14 is. But then we have this value here. So yeah, it's entirely dependent on this one here. It seems too simple. Okay, well, let me know what you think. But that's it. So I'm going to tidy. Well, I'm going to get back to work. Then I'll tidy this up a bit and upload it to my GitHub later tonight or later this afternoon. But that, I don't know. Oh well, let's see. Bye for now.